All right, is everyone back here, more or less? All happy? We're all not following the rules about no food and drink in the auditorium, but that's okay. All right, you're back to where your team is because we're going to have some team question coming up soon. It's all good? All right, let's start. So what's RNN with attention? Have people figure out what attention is during the time you're having coffee and break? We're trying to have attention of of the other one. Okay, so attention is basically, the idea is really the word attention is to pay attention to different parts of the image, for example. So as you process and give out, you can actually guess here, as you look at this bird, you can probably look at it as a different part of the image that are important. So you pay attention to different parts, and as you process over different parts of the image, you produce the caption. So that was the idea of attention. Attention is also used in many other aspects of machine learning. For example, an astrophysical example came up with, which I think people haven't done yet, is that, say, if you want to find anomalies, you want to find weird things in a time series data set, or as you try to observe with more telescope time. When you do a target selection, you might want to pay attention, in this case really mean attention, on certain types of training sets, right? And only certain parts of things you want to get at. So people do use these attention models, they will call it attention models, to try to select the right things they care about. For example, if you want to look for basically bad movies that you need to label on YouTube, people will say, okay, I need to pay attention to these violent scenes. So there are certain things they call attention, but it's fairly generic. It's to sort of like put more weight on certain parts of the image, or certain parts of sequence, or certain parts of a movie. So that's the idea. But this is image captioning with attention. It's a little easier. It focuses on a different spatial location, in this case spatial. It could be over time in a sequence. You can focus on certain parts of the sequence. And so the input image is a bird, and then you have a convolutional neural net that extracted features. And then you do an RNN with attention over the image. What it means is that you basically look at the bird, and then you look at the body of water, so separately. And usually you can look at an image like this, you can basically select these features that are just like birds and body of water. And that's how they then feed it into an RNN that produce the word that a bird flying over a body of water. So that was the idea of attention. And it helps a lot, surprisingly. So what do? So you have an image, the height times width times 3. We have the CNN. You produce some features of some length times depth. And then you have H0, which is the first state. Then you have a distribution over L locations. L, you're looking back at the feature L. And then you produce the weighted features. You actually put some weight on these features. So that's where this attention kind of come in already. And you want a weighted combination of features, so that's why that's sum. It's funny when you do computer science, any mathematical equation seems very difficult, but for scientists, this is like, oh, this, I get it. So usually, if you just show that equation, it's like, okay, you just weigh over all the features, and you sum over it. That's all it actually really means. And then you produce the first word. And you want to produce the correct word, so you actually run it over your distribution. You have a distribution over all the vocabulary that you can imagine. And you basically do something very similar as what we did before with the RNN part. You kind of see it now, the RNN coming back, except that the input is sort of the features that are weighted. Does that make sense? You see this time step going forward with a hidden state, and producing each word sort of going forward. So it all becomes the weighted features are the inputs, and you basically inference the hidden state, and these produces the output words, which are the captions that you really want. And then you do the full backprop with the different truncated parts of it. You compute the loss, and you backprop and change the gradient, and you get all the weight correct. So that was looping all the RNN part of it. But the whole idea is just that you have a different weighted features as inputs. That's the only difference. Okay? Yes, question. Why? Which part?
Y1, Y2.
Oh, yeah. So Y1, Y2 here is I think it's the first output. Yeah. Does that make sense? Good. dot, 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 dot. So you do that all over the place. And here's just how they do it. You know, they have attention on those wings. It's surprising you came up with the word A, but this part coming with the bird, that's not surprising, I hope. And then they figured it's probably some kind of flying over. They're still talking about the bird. But you got to understand that, you know, they're not actually entirely clear why, you know, this is a bird flying over but not flying bird over. So there's some, you know, this is where the training comes in, where the loss has to be reduced when you want a sequence like this. But the over body water is more obvious because it's basically all the water around. And you can see the tension, which is the white highlighted parts. Makes a little bit more sense. But to get the sequence right and all that stuff, it's not just so simple because you need to do a full back prop and you know it has to be sequenced. That makes sense? Yes. There are many questions. Hold on, one at a time.
How on earth does it know that it starts with an A?
That's a really good question. This is probably a lot of sentences that they actually have a lot of similar situations that will have an article and then a noun and then a verb.
How does it know which one?
I guess there's only one bird. That's my guess. I mean, this is unclear how, this is slightly magical, but it's not too crazy. Nobody knows exactly why, you know, these translations work well, and sometimes the failure modes are pretty funny. As you probably will see a few more of these. Yes?
What is hard attention or soft attention?
Oh, it's just like,
Understand these days.
it's just how strong the weight you place on those features.
All right.
Just how large that number is.
So why is attention really hard on the very bottom of the image for flying?
I have very good point. I don't think it works very well here, right? It doesn't even get the bird at all. But I agree. And people will ask, you know, whether you should use soft attention or hard attention. How much weight do you put in for each features?
There's some two stages going on here because, you know, over and flying are relative to some position, right? So it needs to know that it has wings and it needs to know that it's above something.
Mm-hmm.
So the hard attention and soft attention seem to be specifically targeted at different places here.
But these are just, if you just change the weight, that's basically what happens. And I want to show a couple more examples that hopefully helps a little bit. You know, the tension basically get the frisbee. Somehow I found the dog here. The stop sign. A little girl, I don't even know how they can figure out it's a girl, because I can't tell it's a girl or boy, by the way. It's sitting on the bed with a teddy bear. A group of people sitting on a boat in the water, so the people is the tension part. I can barely tell it's a giraffe myself, but I'm horrible with animals. I guess that's not a surprise. With trees in the background. So then there's trees, which is basically getting attention. But the idea is just putting weight on features. That's all. Yes?
It always stops with that.
Hmm?
It always stops with that.
Yeah, all the training examples, I think they throw in probably have a lot of A something. And also the structure is very similar. Have you noticed the structure is article, noun, some verb, and then some other noun. Like it's in a situation. Okay, there's like 3 questions. Who go first? You first, because he hasn't talked all day.
Yeah.
I mean, in the lecture.
The A is just what it starts with. If it started with the, then the sentence would just, the sentence would be dependent on the. So then you would just say, okay, instead of a woman, maybe the woman is. You could just change how the sentence is started.
You have a question?
Yeah, I was thinking about, is the length of the sentence predetermined? Or, for example, I was thinking in the first image, it can be more complete, like, and there is a child, close to the woman. Or, I mean,
I think they're not the same length. I just counted. So
The variable length.
Huh?
Their variable length, the finish is the period, right?
yeah.
Which is also constructed.
so can the machine tells you more about the image than
Then,
you probably can see, or, I don't know.
well, I mean,
I mean,
the
you can
machine,
see the child close to the woman with the frisbee, right?
yeah, the machine is not doing more than what we can do. It's just doing it automatically. I mean, I think the fact that, you know, there's a lot of captioning we need to do online, there's a lots of pictures. It's just humans are not labeling all of them fast enough. That was why it's useful. There's a question right here. Yes. Was that you?
It was the same question.
Okay, good. I think I counted the different number of words. But they're very same structure. Yeah, the structure is very, very similar. And this is the early day of attention, by the way. So 2015. So back in the days, even RNN was new. Just to put you in context. These things have changed a lot since. And captioning has done a lot better than this. And the failure modes you see, I think it's also 2016 or 2015 paper. So just to keep that in mind, 3 years in machine learning is like about 30 years in like a lot of other fields. And it's about 300 papers on archive a day, so just that factor of 10. Yeah. Question again? Yeah, like a group of people. Well, they're not adjective, but it's just yeah. But this is very early work. I think it's the first work that applies attention RNN, by the way. Like back then, it's like unknown how to do it. So go back to challenge question that you had before. How would you use attention to help safeguard, your problems? Just can you do like maybe not 10 minutes, just 5 minutes discussion? Like what would you do to what you had done just now to safeguard all the failure modes that people have seen using attention? Just 5 minutes, 5 minutes. Don't be slow. All right, it's 5 minutes. All right, everybody. We got a group to volunteer. It's 5 minutes. So I know this is an interesting idea and question. We'll have the group in the center to tell us what they thought so far, and just hopefully the rest of them quiet down a tiny bit to give you the floor. There you go.
Oh, I guess we started paying attention to what we focus on.
If you throw away all the possible artifacts of Sloan spectra first, and then do what you said, I think that would work better. I just worry there's a bunch of Sloan spectra artifacts that might cause trouble. Like when they have zero data set, so like zero, the missing data is all zero. Then you have infinite signal to noise. So that's the stuff that I worry about if you're going to implement this part for signal to noise cut. So just like certain floor functions has to be used. Yeah. Any other suggestions? Great ideas. Yes. All right, let's keep going then. So real world examples. This is actually, we use the training set from people answering questions online. I mean, have you noticed, you've been asked to answer these questions all the time to verify you're human. I failed that test like 8 out of 10 times. I don't know how. Prove you're a robot, like prove you're not a robot, I always fail. I think there's some problems with this. But they basically are able to, use this, human given the training set actually answer all these questions fairly well. I mean, you can see how it highlights the answers quite well already. But these are easier multiple choices too at the same time. So this is a homework problem. This is the end of the lecture. Try to implement the choice of problem you picked today. There's a large database of stars in Sloan website that you can easily download. For the planetary ones, I don't know if it's easy to download the Kepler light curves. I know they exist, but I have not downloaded it myself, so I cannot tell you exactly how easy it is to download. Do anyone know about the Kepler light curves? How is it to download? Yes.
I think they're not too bad because the NOS team at NASA have just spent a lot of work archiving and make them available with an API. So if you go on the NOS website,
Do you want to send that information to Slack?
okay.
All right, that sounds good.
I have a question about this Slack. I just wanted to clarify who are the people who can access the Slack.
X is the one.
Help you later, Marianne.
So, because I know some people who don't attend workshop and who are on Slack, and I'm not on Slack, and I would like to know why. Thank you.
Okay. I'm actually not on Slack, but that's a personal choice. I have too many communication means I have to take care. All right, so we could take a 5-minute break, and then I'll start the next lecture, which is on graph neural nets. So stretch your arms, or just like maybe 2 minutes break. Just go use the bathroom and come back. All right? So it's all a new world.